Okay, here I am narrating the answer key to this practice test, hopefully giving you a few insights into how to do this quickly and efficiently and correctly. All right, there are going to be about 4 of these sort of routine problems on the front page, mixture of all the different rules and techniques of derivation. This first one is essentially a product rule, but in the second part there's a nested function inside, so that's going to be a chain rule. So I take the first times the derivative of the second. Cosine derives to be minus sign. Don't mess with the inside, but then take the derivative of the inside. That's the chain rule. Then you're going to multiply those, but not before we've added to it the second part, which is the second times the derivative of the first. So that's a power rule. Then I'm just going to factor out, clean it up. Hopefully that is making sense. If it's worth like 8 points, there might be 1 point for correctly simplifying it. So the second one is a quotient rule. Again, we haven't done a lot of logarithmic stuff with bases that are non-standard, but it's worth knowing. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. I just made that 2x. Try to do it carefully. Then I canceled out a 7 to the x. The derivative of 7 to the x will be just 7 to the x, but then you have to have that adjustment factor, which is always the natural log of that number, that base. When it cancels out, it simplifies down to that. Looks like I forgot a parenthesis. Sorry about that. You could do this with the product rule. You could just rewrite 7 as 7 to the minus x and do that, and you get the same thing. Sometimes it is expressed slightly different. I left the negative x there. You could have stuck it down below. No big deal. This one now is an arc sine or inverse sine function. So you want to know that formula. It's 1 over the square root of 1 minus that thing squared, but that thing is a square root, so when we square it, it cancels. You distribute in the minus sign, lots of magic happens. The 1's cancel, the minus becomes a plus. Then we can take the square root of that, and we get 1 over x. Right here. Then you take the derivative of the inside, that's raised to the 1/2 power, so the 1/2 comes out front as the exponent, becomes to the negative 1/2, which sticks it down below. Don't forget to take the derivative of that inside, the square root as well, and that's a minus 2x. Cleaning it all up here, the 2's cancel, the x's will cancel, and you wind up with just the minus sign, 1 over radical 1 minus x squared. This last one is sort of a test of our logarithmic differentiation skills. It's chain rule. So we take the derivative of the outside, cotangent becomes minus cosecant squared. Don't mess with the inside. Now take the derivative of the inside. Easiest to think of that maybe just by like setting it equal to y. Y equals x to the raised to the tan of x. Whenever you see an x and an exponent, a variable and an exponent, you want to go with a logarithmic differentiation. When you take the natural log of both sides, that exponent comes out front. We get a product rule. When we differentiate, we take the derivative. This is our implicit differentiation skills brought to use. Derivative of ln of y is 1 over y. Don't forget to take the derivative of the inside. That's your y prime. Taking the product rule here carefully. Hope I get that. Then I multiply both sides by y, so I tack on, what is y equal to? It's x tan raised to the tan of x, and then that whole thing just goes up there as the chain rule part. All right, that was a thrill. 5 here is a chance to work on our estimation skills. Don't get psyched out about e to the x. We're just going to go from -2 to 2, going one at a time. You're going to get fairly crude estimates, but you're given that main key point, 0, 1/2, and it's going to be somewhere over 4, somewhere around 1.5, dropping down to 1/2, and then kind of creeping up a little bit. We don't really care what goes on there. We just want to get a sense of what it's doing. It's never going to be negative, for instance. You know, it's not going to cross the x-axis. So then what's the derivative at this point? Well, I use my quotient rule. I carefully follow that. And then I'm able to just evaluate it. I don't have to worry about simplifying. I could have tried to if I'd wanted to, but I don't care. I just plug in 0. E's to the 0 become 1. They do not become 0. But when you multiply by 0, it does become 0. Here you get 1 times 1. So you wind up with -1 over 4 That's your slope. I just put it into point slope form. I wrote it in both forms for you to see, but it doesn't really matter which one you use. On to the next. So here we're finding a function. We're given a function that is the position function, or for a buoy that's going up and down in the ocean in a wave-like form, of course, with the sine function there. So then we take the derivative of that position function to find the velocity. So this drops out to 0. Then I've got 5 times this derivative. There it is. Derivative of sine is cosine. Don't forget to take the derivative of the inside. Sometimes it's easy to forget that. That's pi over 4 times t. So the derivative of that is just pi over 4. Clean it up a little bit. I stick in 0. I get the cosine to be 1. I stick in 10. I get the cosine of 5 pi over 2. Well, that's 0, so that drops out.